I'd like to start with a little difference between what we have been doing and what the other talks were about, where we, as data manager, we are at the service of the researchers. So our first priority is not to make research better, but it's to make the researcher work easier. And here, as an introduction, can skip the content, just see this small video as an introduction of what the question is.
Researchers do love their data. And if their data are lost, the dance stops. While researchers can avoid the crash of a complete data loss by creating backups, proper data management goes beyond just preventing a crash. Today, data are accumulating faster and faster. While packing their data for future analysis, reuse and sharing, researchers often lack a proper system. This strategy may work for a time, but when the amount and complexity of data sets increases, researchers can put themselves in real danger. Because you don't want to waste days sorting out your data, you shall master data safety, organization, naming and computer readability. Then the research process happens smoothly and efficiently. If you want to master data management and increase your efficiency, look for help at a research data management help desk or online. In the next episode, we will see how research data management can help you with your data analysis, so stay tuned.
Okay, so you see also with this video that I used to work with Roman Kellert in Jena a few times ago, and I say hello. But yeah, the question is how to write and organize data for the researchers. And for research paper, it's pretty simple. Most papers organize the same way. You get an introduction, then you get the core of the research, which is the methods and the results. And then you get discussion and conclusion about what you found. And we looked at the data organizations that would follow a similar structure with project management files, like lab information that will correspond to introduction. Then you have the core, which is on one side the method, and then for the result you have the data, the analysis, and the figures. And according like the discussion, you'll get a folder about dissemination material, so reports, text reports, poster, presentation, and of course manuscripts. So we took this into account and create a similar structure as a reproducible package Jeff was talking about, but a bit more complex, with 7 different first level folders. The first one with all project management files, and this can go from accepted grants, so what you're supposed to do during your project. Meeting minutes is quite important if you want to follow what your feedback were along the project. Of course, here will come also data management plans that will explain how you organize the data itself. Then we have one folder about the data material and methods, which has 2 subfolders, one for protocols and one for code, which will be code used to acquire the data. Then we have the data folder here, and we didn't get into the detail of how the data should be organized here. We just have an experiment, data organized by experiment, so each new experiment could get a new folder. And we have one folder for the process data, which is basically the data that you trash before publication because you can be reproduced. Then one for data analysis. And here, if we look at the template we've seen before, the data analysis was in the data folder. And we separate that in 2 so that the data analysis can have a different version control system, for instance. And here again, we can separate the different files by experiments, and we can have one file for code libraries, so dependencies, and we also add a subfolder for pre-registration, which is basically a text describing how you will analyze the data before you acquire the data. Then we have one for figures that can be also separate into different experiments, or have one simple for all the figure you share with your coworkers. And then we have one folder for the dissemination with report and conferences on one side and manuscripts on the other side. So we separate the two because often the PI just want to have a look at the manuscripts and doesn't care about the rest. Right. So that's basically our output. And I'd like to give a small history of how we got there. So I started to work for the CRC in Berlin in April 2019. And in September, I started to contact other neuroscience CRCs to see if we could work together on, because we have the similar issues. Two different CRC at position like mine, and we decided to work together. And in January 2020, I created a folder structure template, the first one for one lab, which was very similar to what you've seen in the previous work. And then I told the others, and one another CRC also created this folder structure, and we looked at them and they were quite different. So we decided to work on that together. And we created two different templates that were quite different to see what researcher would like to see as a template. And we ran a survey, got 50 responses from the different researchers that were working as a different CRCs. So all neuroscientists, but some of them were doing computer science. Most of them were doing wet lab science. And we got results that we analyzed, and we published this analysis in January 2021 in a blog post. And the output was basically that half the people preferred one template, the other half preferred the other template, but all agree that the template would be good. Right? And so we created a new template, which was basically taking more of the qualitative feedback we got from the people. And now we just pushed it to GitHub, and we started a website to document it. So the feedback was basically that it's good structure is worth a lot of time, right? People were happy to have a template to organize a file, and they thought it would be good that if everybody is using the same template, it will facilitate collaboration. So one other feedback we got is that there's different levels of organization. There is the project level, which gets the organization I presented before. There's also an experiment level. So one project is made of several experiments. And to take that into account, we had this idea to create different subfolders for each experiment at different places in the project level organization. But there were also some laboratory level or a cross-project level. So for instance, you may want to have figures from different projects in a single folder, or all your conferences at the same place, or all your conference documents. Especially for PI, you may just want to have a look at all manuscripts that have been written in the lab. And to do that, we will need a cloud solution that folders are basically put on the cloud and organized differently for different computers. And to do that, we'd like to use the Git submodule technology. And here I will talk a bit more about the technologies that would make this the use of the template easier, and adoption may be better. So the Git submodules is a technology which looks a bit like magic. So it's a Git technology. I think most of you know what Git is, which is a version control system. And what Git Modules do is that it link folders in a Git repository to a different Git repository. So if you look on your computer, what you see is basically those kind of folders. So it looks perfectly normal, right? You have folders, you can put things in it, and you work as you were used to work. But if you look at the server version, those are not folder. Oh, sorry. It's not folders. It's linked to different repositories. That means that these subfolders can have a different version control system. It can also be published independently of the others. Okay, so the next step there is that you can organize things differently for different people. So if in the middle you'll have all the documentation linked to a project, including an open wiki and issues on the server, which is visible for everyone, you can basically synchronize differently on different computers. And this means that, for instance, on the lab computer, you may want to have everything, while at home, you don't want the raw data, which took too much storage, and you just want to work on the derived data and the analysis. It can also mean that the PI can just have a look at the manuscript and the figures and doesn't have to synchronize all the data. And this has to be set once and then can be basically synchronized independently, so everyone has the latest version of the files. Also, it doesn't see everything. So it works is that we took this folder tree template and we had synchronization scripts so that it's easy for the researcher to just synchronize the version with the server version. And it uses the submodule technology to create basically submodule with that. Then different computers can synchronize with the server. And since it's a Git server, it can be automated with an own backup on a one server using GIN. And it can also use a GIN-DOI service to publish directly only a part of the folder tree. The Tonic tool should be a robot that create the repository, and that's in development, or can add experiments, or can do other administrative work on the files. So the idea is to have large file support using the Git-Tonic technology, and that's due to the GIN, which is developed by Gnode in Germany. You have an easy publication, also thanks to GIN. And on top of that, you had this easy administration via the Tonic tools in the synchronization, so that people don't have to use command lines. And we have this research-oriented template. Right, so we basically, with GIN-Tonic, it's bringing vigor to the Gnode infrastructure by adding more functionality and simplifies administration. It's an open infrastructure, so both GIN and Tonic is open source and easy to install via Docker, and they're maintained by Gnode. So and the idea is to link with this project data, project and lab management. Data management by having a simple backup, to have project management with issue and pull request, and use organization for data sharing in the lab. Thanks to the folder template, we get the file organized, and one organization for all projects makes it easier for collaborators to look at your files and And you can also use a Git module technology to get one folder for the whole lab. This will mean that you can share information in the whole lab, that it will be synchronized on each project at the same time and directly. For the data creator, the point here is to access the data and be able to talk with the researchers and give them advice early on in their process so that the data is better described and documented and easy to publish in the end. So we have the GitHub collaboration tools in GIN, which make project management easier. And in the end, it's all for the researcher. And to quote this day, which says that data management is or metadata is a lot better for the future. Or I will add that it's not just the future of research in general, but it's also for your own future self. And that by documenting data and using tools that make it more easy to find things again, you help yourself. And in the end, to look back at what Daniel showed, that saying that making better data analysis is basically investing time that you don't have to spend doing peer review. I will say that with research data management, you go one step further because you basically gain time in the end. And so the Tonic team is on GitHub now. You can just go there, github.com Tonic team. We have basically the template and the documentation website and the scripts we're working on. That's all work in progress, but we hope we'll soon get to a position where we can actually use it for real with real researchers. And with that, I'd like to thank you and open the discussion.